This is from the implicit derivatives differentiation lesson, example number 6. The first thing you're going to notice on the smartboard example is that that ellipse did not copy properly from what you have on your sheet. So let me just re-sketch this, and then we'll start this in 20 seconds here, or 10 seconds here, whatever it takes. What I did is I went back to the x squared over 9, so horizontal shift of 0 and a stretch of 1/3, so it goes 3 to the right, 3 to the left of 0. Same thing with y squared over 4, or y over 2 all squared, vertical stretch of 2 up and 2 down from 0. So our ellipse really crosses at plus or minus 3 on the x-axis and plus or minus 2 on the y-axis, which now means where x is 1, we can find a tangent slope on both the positive side and the negative side. So that's our objective, is to find the slope here. Most of us don't like fractions, so right from the get-go, let's just take and times the whole thing by 36. And again, we're timesing both sides of the equation by 36, so we aren't really changing the equation, we're just changing how it looks. So 36 times x squared divided by 9 becomes 4x squared. 36 times y squared divided by 4 becomes 9y squared, and 1 times 36 is 36. So we're just changing our equation so it doesn't have fractions in it. The original form of the equation is nice to see the stretch factors, but this equation is much nicer to work with in terms of finding derivatives. So let's tell everybody that we're going to take a derivative. And now let's take the derivative of 4x squared. So 4 times 2 is 8. Increase x squared by 1 becomes x to the 1. Derivative of 9y squared. 9 times 2 is 18. The exponent on the y value decreases to degree 1 as well. But the chain rule is telling us this is not a base of x. So I want to take the derivative of my non-x function, the chain rule part, and then I also want to take the derivative of 36, or the derivative of a constant. Slope is 0. So let's just clean this up a little bit. We have 8x plus 18y dy dx, or y prime, equals 0. If I want to solve this for dy dx, it's like solving for a two-step equation. I'm going to minus 8x from both sides, and then after I minus 8x, I am going to divide by the 18y. So if I want to find the slope of my equation, I'm just going to simplify that expression. So the slope, I need to know both the x value and the y value. These terms both divide by 2, so I have negative 4x over 9y. So if I'm supposed to find the slope when my x value is 1, I better find the y value with it. And I can use whichever equation I want. I can use the 4x squared plus 9y squared equation, or I can use the x squared over 9 plus y squared over 4 equation. Let's go with 4x squared plus 9y squared equals 36. Put x equals 1 into the question. And the reason I'm doing this is that knowing only that x equals 1 isn't enough information to give me the slope. I have to know the y value to know the slope of the point. So I'm going to go 4 times 1 plus 9y squared equals 36. Subtract 4 from both sides. 9y squared equals 32. Divide both sides by 9. I get y squared equals 32 over 9. And then we're going to square root both sides. And this is where it's now a relation, not a function. I'm going to have plus or minus the square root of 32. And instead of 32, I'm going to write this as 16 times 2, so I can simplify a little bit. Divided by 9. So my y value is plus or minus 4 root 2 over 3. So those are my y values. And I want to find the slope for each of those y values. So one point is 1 with 4 root 2 over 3. And my other point is going to be 1 with negative 4 root 2 over 3. The slope, which is my derivative, is negative 4x over 9y, negative 4 times x over 9 times y. If I simplify this a little bit, the 9 and the 3 cancel out right away. I have negative 4 times 1. I have 3 times 4 root 2. The 4's can cancel, and my slope is negative 1 over 3 root 2. And that's the slope at the point that's on the top of the ellipse. And similarly, we can go through all the same math and find the slope that is on the bottom of the ellipse. Negative 4 times my x value, 9 times my y value. The 4's cancel, the negatives cancel. So my numerator is 1. The 9 and 3 cancel. So it's 3 root 2. So the bottom point has a positive slope and the top point has a negative slope, which is what you can see from your ellipse.